Hello students, this is Dr. Anita Raj, your chemistry mentor, welcoming you for one more session in solid state. In this session, we shall see how to find out the number of atoms in a unit cell in detail.
Okay, in various unit cells, there are four types of lattice points located at the corners, faces, body center and at the edge of the unit cells. So before going into the topic, we'll show you how many corners, faces and edges are there in a unit cell, right? See, this is a unit cell and this is a cube, and let me show the corners now. 1, 2, 3, 4, 5, 6, 7 and 8. So totally 8 corners are there in a unit cell. Okay. Now I am going to show you the number of faces. 1, this is the face. 1, 2, 3, 4, 5 and 6. Okay. So 6 faces are there in a unit cell, right? And now I am going to show you how many edges are there. See, this is the edge. So 1, 2, 3, 4, 5, 6, then 7, 8, then comes 9, 10, 11 and 12. So totally 12 edges are there. Okay. Now let us see how to find out the number of particles in different unit cells. Okay. So there are different types of unit cells: simple cubic system, and then body centered, face centered, end centered, edge centered. Okay. So let us see one by one right now. So let me explain the simple cubic system now. In simple cubic system, or this is otherwise called as a basic unit system, the constant particles are present only at the corners. Okay, we can see the constant particles only at the corners. Now let us consider an atom is present in one of the corners of this unit cell. So I am placing an atom, and now as I told you earlier, this unit cell will be having so many adjacent unit cells. Okay, this will be in contact with other unit cells. Okay, now this atom is being shared by this unit cell also, and again this will be in contact with another unit cell, and again this will be in contact with the next adjacent unit cell. Now see here, this atom is being shared by the four unit cells now. Okay, now this unit cell, above this unit cell again another unit cell will be there. Okay, and again above this another unit cell, and above this again one more unit cell. Okay, and finally we will be having another last one, right? So now you can understand that this atom, that is the atom which is present at the corner of this first unit cell, is being shared by 8 unit cells. Okay, it's been shared by 8 unit cells. So hence only 1 by 8 of this atom belongs to this particular unit cell. Okay, only 1 by 8 of this atom belongs to this particular unit cell. This cell has now 8 corners. Okay, 8 corner atoms. So the total number of particle contribution can be calculated as follows. Well students, in a simple cubic lattice we are having 8 corners, is it not? So there are 8 corners, right? So from one corner atom the contribution will be 1 by 8, is it not? It is 1 by 8. Since we are having 8 corners, then when you are calculating, the number of particles will be 1. Okay, so the number of particles from simple cubic lattice is 1. Understood students? Next we shall calculate for the face centered unit cell. In face centered unit cell, the constant particles are present at the center of each face. Okay, so the constant particles will be present in the center of each face, and also in addition to this we can see the constant particles of the atoms, ions or molecules at the 8 corners. Okay, so in 6 faces as well as in 8 corners we can see the constant particles in a face centered cubic lattice. Okay, but in face centered, each atom located at the face center is shared by 2 adjacent unit cells. Okay, let me show how it is. See, I am placing an atom here on this unit cell. We can see the atom on the face center of this unit cell, and now again this unit cell will be in contact with another unit cell at the top. In this case, this atom is being shared up by this unit cell as well as by this unit cell. Hence only half of each atom belongs to a unit cell. Okay, so only half of this atom will be contributing to this unit cell, and the next half will be contributed to this unit cell. Understood? So in FCC there are 6 faces and 8 corners. So let us calculate the number of particles here now. Okay, in face centered cubic lattice it has 8 corners and 6 faces, is it not? So it has 8 corners. So 8 corners and plus 6 faces, is it not? 6 faces. So in 8 corners we will be having 8 atoms, and in 6 faces we will be having 6 atoms, is it not? But from 8 atoms, from the corner atom, from each corner atom there will be only 1/8 contribution, is it not? Contribution will be 1/8, whereas in faces contribution will be half. From one atom there will be half contribution to that unit cell, is it not? So when you are simplifying this, you will be getting from the corners, you will be getting 1, is it not? 8 into 1/8, 8 into 1/8, that will be 1. 6 into 1/2 will be, what's the answer? 6 into 1/2, it is 3, is it not? It is 3. So that's equal to 4, right? So 4, now total number of particles or total number of atoms present in FCC, that is face centered cubic lattice or face centered unit cell, is 4. Understood, students? Hence, FCC has 4 constant particles totally per unit cell. Understood? So next we shall see how to calculate the total number of particles in a body centered unit cell. See, in body centered unit cell, the constant particle is present at the center. Since this is the unit cell, we could see the atom inside this unit cell. Okay, it will be present at the middle of this unit cell. Okay, at the that's why it's called as body centered. So along with this, in addition to this, the particles can be seen in the corners also. So in body centered unit cell, the constant particles are present in the corners as well as at the center. Okay, but the atom at the body center wholly belongs to this unit cell. Okay, since in which it is present. Okay, therefore the particles present at the center of the unit cell contributes 1 to the particular unit cell. Okay, so in BCC there is 1 atom at the center and 8 in the corners. So let us calculate the total number of particles here now. This in body centered cubic lattice, it has 8 corners, is it not? 8 corner atoms. Okay, 8 corner atoms, and then it has 1 body centered atom, is it not? Only 1 body centered. So body centered. So this body centered atom is see, this 1 body centered atom, it belongs to the whole unit cell. Okay, it's not shared by any other adjacent unit cells. Okay, so it holds some, it belongs to the body centered cubic lattice. Okay, but here the 8 corners will be shared by 8 adjacent unit cells, so 1/8. Okay, so totally how many total number of particles? 1 plus 1, that's equal to 2 for body centered. Okay, so 2 particles, total number of particles Z will be 2 for the body centered cubic lattice. Understood, students? Next we shall see how to calculate in edge centered cubic cell. In edge centered unit cell, the atoms are present at the corners as well as at the center of each edge, as well as at the, this is the edge. Okay, so at the center of each edge we can see the constant particles. Okay, so altogether here we are having, in an unit cell we are having 12 edges. As I have told you earlier, this cubic unit cell will be having 12 edges. So we can see at the center of each edge we can see the constant particles. Okay, so each atom located at the center of the edges is shared between 4 unit cells. Okay, let me show how it is shared by 4 unit cells. See here, this is the another unit cell, and this atom is being shared by the next unit cell, and again another unit cell which is placed above. Okay, and now another unit cell here I am placing. Okay, now this atom which is present at the center of the this unit cell's edge is being shared by this unit cell, and then this unit cell, and this unit cell. So 4 unit cells are been sharing this particular atom. Hence only 1/4 of this atom belongs to this unit cell, and the next 1/4 belongs to this unit cell, and next 1/4 belong to this unit cell. Understood? In edge center, therefore in edge centered cubic cell there are 12 edges and 8 corners. So let us calculate the number of particles here now. So how to calculate for the edge-centered cubic lattice? So as I told you earlier, the edge-centered cubic lattice, it contains 8 corners, is it not? It has atoms in 8 corners which is shared by 8, is it not? So if it is shared, then again 1/8, the contribution will be 1/8 as usual. And then in edge center, how many edges are there? 12 edges, okay? 12 edges are there, right? 12 edges, and each edge will be shared by 4 unit cells, 4 adjacent unit cells. So it will be 1/4, okay? It is 1/4. So what could be the total number of atoms or the particles present? It is 1 plus 3, that's equal to 4, okay? So total number of particles present in edge-centered cubic lattice is 4. Understood, students? Hence the number of atoms per unit cell in such case is 4, 3 from 12 edges and 1 from 8 corners, okay? Next we shall see how to calculate in end-centered cubic cell. In end-centered cubic unit cell, 8 atoms are present on the corners, 8 corners of the cube. 2 atoms will be placed opposite in opposite faces, okay, like this, right? And now these 2 atoms are present at the center of each atom, and this contributes only half a portion of the cell. The reason is this atom will be shared up by another unit cell which is placed above. See here, so that only half of this atom will be shared by this unit cell, and the next half will be given to this cell which is placed above this unit cell. Understood? So only half of each atom will be contributed to this unit cell. Understood? So we shall calculate now. See, in the end-centered cubic lattice, as I told you, it has 8 corners, obviously 8 corner atoms, okay? 8 corners, and again contribution will be 1/8 plus it has 2 atoms in opposite faces, okay? 2 atoms in opposite faces. So 2, right? 2 into, and each will be shared by 2 adjacent cells, okay? So 1/2, right? So that will be equal to 1 plus 1, that is equal to 2. Understood, students? So totally 2. All right. Well, fine, students, you might have understood how to find out the total number of atoms contributed to different types of unit cells. I shall meet you with another important topic in a short period. Until then, it's Dr. Anita Raj signing off from you. Thanks for watching.